Hi, welcome to my video on the derivatives of exponential and logarithmic functions. So far we have learned how to find the derivatives of powers and then constant multiple of powers and then sums when you add two powers together. And if you have sums and if you have two sums coming as a product, so two pieces coming together as a product, we know how to find the derivative of those. And when we also know if we have a fraction of two functions, one on top, one on the other, how to find the derivative of the fraction or the quotient. And then in the previous video, we learned how to find the derivatives of some special functions which are trigonometric functions, right? Sine, cosine, tangent, secant, cosecant, and cotangent, the six trigonometric functions. And then if you combine them together with the other rules, power and quotient and product, you can actually pretty much nail most expressions involving those, right? And then now we are going to tackle two more very important functions, and one is the so-called exponential functions, which is e to the x, and the other is natural log of x. And why are these important? Because a lot of things in the universe grow and decay using exponential functions. Population growth, financial growth, and even when there's a global pandemic which came in 2020, the growth of the pandemic becomes scary when it becomes exponential, right? Okay, so if you want to find how fast at a certain point the pandemic is growing, right? Or if you want to find how fast the deer population is growing, how fast your money is growing, okay, then you need to find how fast means you need to find the derivative. And similarly, natural log of x is the inverse function of the exponential function. And then there are so and that is often used to actually to scale down something. So if you have a big scale, we use the logs to convert that into a smaller scale and things like that. So we need to find the derivative of the natural log of x. So the most beautiful thing here is that these derivatives are really simple. Once again, I cannot give you the proof at this very short course, but the derivative of e to the x is really e to the x. Nothing happens. And that's a remarkable ability about e to the x. If you take the derivative of e to the x, it is e to the x. And on the other hand, if you take the derivative of natural log of x, it's just 1 over x. All right, so let's try to see whether we can use them in an exercise, right? Okay, so let's take an example. So first of all, let's take this example. You want to have a function sine x plus 1 times e to the x. Well, immediately you will see that that's a product. So you can use product rule. So write 1, okay, derivative of 2. Now we need to find the derivative of the second piece. And because the second piece is e to the x, we know that the derivative of e to the x is e to the x. So that's the second piece derivative is e to the x plus, and then write 2, which is what? E to the x, and that's e to the x right here. And derivative of 1, right? 2 derivative of 1. Okay, so what's 1? Sine x plus 1. So the derivative, that's a sum. So you take the derivative of sine x, which is cosine x plus 0. And so you get cosine x, and that's that. So write 1 diff 2, write 2 diff 1. Okay, and then if you file this out, okay, you'll get e to the x. You can rather than file it out, you have a common factor e to the x of all of this, so you take it out and then you get e to the x times, if you take the e to the x from here, you get sine x plus 1, right? And of course, if you take e to the x from here, you get a cosine x. I need to add that one, okay? So plus cosine x, okay? So I hope you see it. Let's try to bring it down, okay? No, happened. Okay, so it's e to the x sine x plus 1 plus cosine x, okay? Or let's do another example. Now this time using the natural log of x. So y is equal to 1 minus natural log of x over 1 plus natural log of x. So if you want to take the derivative of that, okay, so this is a quotient. So what you do is you use a mnemonic like low d high. So low is this, d high. So you need to find the derivative of this. So this is a subtraction. So the derivative of 1 is 0. that's 0, minus the derivative of natural log of x is, we know that, as 1 over x. So it's really 0 minus 1 over x, which is negative 1 over x. So this is d high minus high d low. So 1 minus natural log of x high. You want to take d low. So derivative of the low, which is the derivative of 1 is 0, plus the derivative of natural log of x is 1 over x. So 0 plus 1 over x, which is just 1 over x. And all over low squared. So all over 1 plus natural log of x squared. So if you follow this out, you get negative. So negative 1 over x times 1 is negative 1 over x, right? And then natural log of x times negative 1 over x is negative natural log of x over x, right? And then when you go to this part, you get again negative 1 over x times negative 1 with a negative in front is negative 1 over x. And then 1 over x with a negative natural log of x is negative natural log of x over x. With the negative, it becomes plus, so plus natural log of x over x. So now you can see that the natural log of x over x and the negative and the plus cancels off. So the natural log of x terms goes off, and you're left with a negative 1 over x, and negative 1 over x becomes negative 2. So you get negative 2 1 over x, right? At the same time, you also get this piece at the bottom, which is 1 plus natural log of x squared. So that's the answer. So as an exercise, I will leave you to do this, right? Okay. All right. This one right here. Okay. All right. So pause the video and then do it on your own. And when you come back, restart the video. So all right, so when you come back, so this is a sum straight away. So first of all, you can take the derivative of each piece. If you take the derivative of the first piece, you get 2 times the derivative of e to the x is e to the x. So 2 times e to the x plus you have a 5 is a constant. You can take it outside, and the rest is what? A product. So right one is, so I took the 5 outside. So right one is x squared times the natural log of x is derivative 1 over x plus natural log of x times 2x. Natural log of x times 2x. So, so 2 times e to the x plus x squared times 1 over x. So x is 5x plus 5 times 2x is 10x natural log of x. So that's the answer, right? Okay, for that. Okay, and all right, so that's it for this video, and then I will see you again with a different video. I hope you enjoyed it. So this video's purpose was to introduce two really main derivatives of some cool functions. The derivative of e to the x is e to the x, nothing happens, and then natural log of x, we just go 1 over x. Okay, 1 over x. All right, thank you for watching.